Hello everyone, it's another fine day for arrays. The last problem for in-place operations is remove element. Now this is a problem I have solved before, but I thought it would be good to review because I've solved it in two different ways. That's right, two different ways I have solved this problem, and I think it is quite interesting. So here we go. Removing an element. They are going to give us an element to remove, and it's going to be val. And the what we're removing it from is going to be the array. So we have a data structure containing numbers, and then we have data, a number that we want to remove from the data structure. And we're going to return the numbers in place. And so return the number of elements in nums which are not equal to val. The remaining elements of nums are not important, as well as the size of nums. So what that means is we have two elements here that are not the number we're removing, and when we take these two numbers and we move them this way, we don't care about the numbers that come after it. That's all that means. And so we have two different methods. We have vanilla JavaScript, I guess. And then we have filtered, using a filtered array, using the filter method. So vanilla and then with a filter. So how does a filter work? Well, here we have an example. Const nums 0, 10, 20, 30, 40, 50. And so we have nums.filter, the num for each num. This is a new variable, num. Return, the arrow is like return. For num, return num is greater than, for each num, return the ones that are greater than 20. And so the filter method does not modify the original array. If you want to log the filtered array, you need to assign the result of filter to a new variable or log it directly. And so you have the filtered nums. So this is necessary. Having another array to store the numbers. It does not modify. It is a method for creating a new array from the old array. So here we have a new array, filtered array. And so we're asked to return k, the number of elements that are not equal to val. And so those are the numbers, those will be equal to the length of the filtered array, because if we filter out the numbers we don't want, we'll be left with the numbers we do want, and then we can count them or measure the length using the dot length property, and then we can simply overwrite the values for I with the value for the filtered array, which is 2, and then it's 2, and we do not care about these elements. And then over here, we're doing the same thing, except we have a pointer that's going to point at the place we're updating. So we have a little arrow. So this is k. We have an arrow for k. So k is going to point at 3. And if it's a number that's not 3, then we'll update it. Currently, these are both at the same position, so 3 is not equal to 3, that is false. So I moves to the next number. I is at 2. 2 is not equal to 3, that's true. So the number at this place becomes 2. So I can move 2 here. I'm just going to copy it. Two is going to be moved right there. And then we're going to go to the next position. K gets updated. K is now pointing here. And so where are we? So I was pointing at 2. Now it's pointing at 2 again. And 2 does not equal 3. That's true. So this value is going to be 2. So it's going to have another 2. 2 is going to be moved here. And then we have a value, I is here at 3, and that 3 is not equal to 3, that's false. So we do not move it. And so we have successfully moved all of these things. And leetcode says it doesn't care about these, so just pretend they don't exist. K was moved twice, so return K, which is the number. K was moved twice, therefore, because it was only updated when it wasn't equal to 3, then that tells us that the number of values that we have that are not equal to 3 are 2. So K is equal to 2. And so we have the same result. Okay, I'll catch you guys on the flippity floppity. Have a nice day.